Okay, this is from 7.3 homework. Someone asked about number 6 and number 7. So I'm going to go ahead and write down number 6 first. Am I? No, I'm just going to look at it. Okay, if I look at number 6, the first equation already has the y canceled out. So I'm going to use this equation, keep it the way it is. And then I'm going to use equations b and c to cancel the y's out again. Okay, so let me see if I do equation b. Okay, and then I want to cancel it with c. So let me multiply equation c by -1. I canceled the y's. Okay, now I can go ahead and use this new equation I got here with the first equation to solve for x and z. So let me copy equation A down. X plus 2z equals 5. And then what's this one? -3x minus 6z equals -15. You can solve however you like. I could multiply the first equation by 3. I could divide the second equation by 3. I'm going to divide, and the only reason is because it keeps the numbers smaller. But our work should be the same in 1 second, even if you didn't divide. -x minus 2z. Okay, so if I do this, cancel, cancel, I get 0 equals 0, which indicates that there are infinite solutions. Okay, now because there's infinite solutions, I'm going to use parameter a to describe my solution. Now it's up to me which variable I want to choose to let equal to a. But I am going to decide between x and z because in my 2-variable equation, those are the 2 variables I have. Because x looks like it's easier to solve for, I'm going to let z equal a. This is not the only way to do it. Okay, so if I plug z equals a, I get x plus 2, a equals 5. So x equals 5 minus 2a. Okay, I have x, I have z, I need y. So I'm going to have to plug into, I think I'm going to plug into equation b. So if I plug into equation b, I have 3 times x minus y minus z equals 1. And I'm solving for y. So what is this? Okay, now I have x, y, z, so I'm going to express my answer as an ordered triple. X, y, and z. And just make sure that you prove that this was infinite solutions before you went forward and set the parameter equal to a. Okay, yeah, now I'm going to look at number 7. Okay, now 7 is right here. I have 3 variables and only 2 equations, which means this is a non-square system. So I'm going to assume it's a dependent system. And normally I would cancel a variable first, but actually in the second equation, the y is already canceled. So I'm going to use the second equation, and I won't even have to do the first step. Although you could, it won't mess up the equation. Let's see, which one's easier to solve for? It's easier to solve for z, so I'm going to plug in x equals a. Okay, now I have x, I have z, I need y. So I'm going to plug into the first equation. So x minus 2y plus 5z equals 23. So my ordered triple is X, Y, and Z. And if you selected to let Z equal A, you would get a different ordered triple that's equally correct. And remember, I didn't have to prove this was infinite because it was non-square, and it didn't reveal that there was no solution. I could assume that I needed to use parameter A.